Hey guys, welcome to the last last lesson of Unit 6, which is solving rational equations. So basically this is what we've been building with all of our skills of adding, subtracting, multiplying, and with rational expressions is now we're going to be able to put those skills to use. So the first example here, equation with one solution. One thing that we have to be careful of, we didn't really talk about this yet, but you have to remember that on the bottom of a fraction, we can never have zero. So when you look at these equations, you have to look at them and decide, because oftentimes you're going to get a variable on the bottom. So notice we have x and x. So the only value that we could solve for that would make the bottom zero is actually zero itself. So before we do any solving, what we're going to do off to the side here is just note that x cannot equal zero. That is a solution that will not work. If we get that as an answer, I'll tell you what to do if we get to that point. So here, for example 1, what we need in order to subtract fractions, because this is an equation we want to solve. Remember that when we're subtracting fractions, we need a common denominator. And that's actually what we're going to do for every single fraction here. So notice we have an x and a 2, and then another x. So on the first fraction, using the information that we had before from the previous lesson, we're going to multiply by 2 over 2, because we want to get 2 and x as factors on the bottom of that one. This one, we're missing a factor of x, so we're going to multiply by x over x, and this one, we're also missing a 2. So we're going to multiply by 2 over 2. So 2 times 3 is 6, and then the bottom we get 2x minus x times 1 is x over 2x. Lastly, we have 12 times 2 is going to be 24. And then 2x is going to be, or 2 times x is 2x. Now that we have all of the same denominator, this is great because here's the trick. Once you have the same denominator, that tells you that the top is our new equation. Once we get that, we can actually get rid of the denominators and just make it a 6 minus x equals 24. Turns into a really simple equation. Now we know what we would do is subtract 6. We would get negative x equals 18, and then we would have to actually divide by negative 1, because we got to get rid of that negative sign, and we get x equals negative 18. Kind of a weird number, but what we can do to check this out is actually plug it in. All right, so we can plug it back in. I'm not going to do that for this problem just for the sake of time. But remember, the goal is to get the common denominator, and then you can get rid of the denominator because the tops would have to equal. Just make sure that you account for your restriction. We're not always going to have a restriction, but a lot of the time we will when we're solving. All right, let's keep going. Equation with an extraneous solution. So an extraneous solution means an extra solution that doesn't actually work. So 5x over x plus 1 equals 4 minus 5 over x plus 1. This time we have x plus 1. Remember, if you want to make this into a fraction, you just put it over 1. So the factor that we're missing is x plus 1 on the bottom of this one. So what we're going to do then is we are going to multiply just this one by x plus 1 on the top and the bottom, x plus 1. So we're going to leave this fraction here the same, 5x plus 1 equals distribute 4x plus 4 over x plus 1 minus, and then this one also stays the same, 5 over x plus 1. We just changed that one in the middle that didn't have a common denominator with the other two. Now before I forget, remember, we want to think about the restrictions. What would make the bottom of each of these fractions 0? And in this case, x plus 1, well, the only value that would make that 0 is the opposite, negative 1. Okay, so x cannot equal negative 1. That's going to be a restriction. Now that we have the same denominator, let's just look at the tops, treat those like one equation. So 5x equals 4x plus 4 minus 5, and it's a pretty simple equation for us to solve. We're going to subtract 4x, we get x equals, that is just going to go away, positive 4 minus 5 gives us negative 1. So here's the extraneous solution, because notice this can't happen. this is a contradiction. You can't have x equal -1 and x not equal -1. So for this one, we're going to say no solution. There's not truly an x value that is possible for this, because we would end up with 0 on the bottom. Sometimes, though, we will get two solutions. First thing I want to do here, I forgot to do it right away in the last one, but notice, take a look at your fractions. This one down here is actually going to factor out. We're going to do that right away. So x squared minus 4 is x plus 2, x minus 2. And we notice we have a factor of x minus 2 over here. And this one, we don't have anything. So we're going to put that over 1. So now what we're going to do is realize that there are a couple values that we actually can't have on the bottom. For this one over here, x minus 2, we can't have a positive 2, because then 2 minus 2 would make it 0. This one, we have two sets of parentheses, which means there's two values. We have x minus 2 again, which would be the 2. But this one, what value would make that 0 is -2, just the opposite. All right, so now we have two restrictions this time, which is fine. Just be cautious of that. The biggest factor that we have for our common denominator, we have x plus 2 and x minus 2. So what we're going to do to this one is we're going to multiply by x plus 2 and x plus 2. And then this one, we're going to multiply by x plus 2 and x minus 2 over x plus 2, x minus 2, because we're missing both factors on that one. All right, these can kind of get a little messy. So this first one, we're going to have to FOIL. So I'm going to do that first. X times x is 3x squared. X times -2 is minus 2x. 2 times 3x is plus 6x. And then 2 times -2 is minus 4. All over. You can just leave the bottom the same because we're going to get rid of the denominator. We just want to make sure we have a common denominator for everything. Okay, and then over here, this one stays exactly the same. We can actually just leave it as x squared minus 4 because that's the same. Those are exactly the same. And then plus, and since they are exactly the same, this here is the same as x squared minus 4 over x squared minus 4. If we just were to multiply back out, but we don't need to do too much work there. Now that we have that figured out, let's go ahead and not worry about the bottoms, just focus on the numerators in one equation. We're going to get 3x squared minus 2x plus 6x minus 4 equals 6 plus x squared minus 4. We want to get everything on one side, set it equal to 0, since we have an x squared. So the first thing I'm going to do is subtract x squared. I'm going to subtract, well, let's just start there. Combine like terms on the left side. We're going to get 2x squared plus 4x minus 4 equals, and then these two, it's going to be 6 and -4 is going to be positive 2. I'm going to subtract 2 now, subtract 2. We get 2x squared plus 4x minus 6 equals 0. Now notice right away we can actually factor out a 2. So if we take a 2 out, we're going to get x squared plus 2x minus 3 equals 0. We can factor that as well. So it's going to be 2 times x. Signs are going to be different. The plus is going to be bigger. So factors of 3 that have a difference of 2 are plus 3 and x minus 1. And when we're solving for these, remember it's just the opposite if it's a single x. So we're going to get x equals -3 and x equals positive 1. Check that with your, oh, I forgot to put the slash here because that can't be. I'm just going to bring this down here. So x cannot equal 2 or -2. So the restrictions are good. We always want to list our restrictions. That's going to be part of your answers a lot of the time. And then they don't match up with our actual answers, so we're good to go. Those answers are fine. All right, last example before you get to try some on your own is cross multiplying. This is a common thing you've seen back in the day. Back in the day meaning like middle school. It's used when each side is a single rational expression. So when you see just one fraction on both sides, that's when we're going to use the cross multiplication method. And what you do is you take a times d. It's called the cross because it basically forms an x there. A times D is equal to C times B. So what we're going to do here is just multiply the cross sections. So 3 times x plus 4 is equal to 1 times x squared plus 4x. So we're just going to call that x squared plus 4x like this. All right, now we're going to solve. So distribute the 3. We get 3x plus 12. And then we have x squared plus 4x. We want to get everything on one side, preferably on the x squared side. So I'm going to subtract 3x and subtract 12. And this side is going to become 0 equals x squared plus x minus 12. And that's going to factor into x plus 4 and x minus 3 because we didn't have, or excuse me, because the signs are different and the 4 is bigger. Okay, so the solutions for this are going to be -4, the opposite, and +3. But what I forgot to do, and it's fine if you forget to do this too, just make sure you do it at the end, is we didn't list the restrictions. So the bottom of this one, if we were to factor this out, it would have been x and x plus 4. And then this one, it's just x plus 4. So the restrictions are actually x cannot equal, when you have an x on the outside like this, 0 is what we're going to get for one of them. And then x plus 4 is just the opposite, so -4. So notice we can't have this. You can't have one that's a restriction and a solution, so we're not going to include that one. So that's why we have to do the restrictions, because sometimes we lose out on one. So the only answer here that works is x equals +3. -4 is a restriction, so we can't use that one. All right, go ahead and try these out, and let me know if you have any